Hello friends, welcome to my channel. This is Isro Strength of Material Part 8. Question is, which of the following statements is correct in case of a curved beam? A neutral axis is nearer to center of curvature compared to centroidal axis. B. Neutral axis is farther to center of curvature compared to centroidal axis. C. Neutral axis is matches with centroidal axis. Not possible. Neutral axis shifts above or below centroidal axis depending on the loading condition. Here A is the answer. Next question. In case of a horizontal beam loaded under bending, the point of inflection or point of contraflexure corresponds to point on the beam. This is very important for upcoming Coal India examination. And for other examination also, this is very important. Point of inflection or contraflexure. Here zero bending moment, also beam changes curvature, also bending moment changes sign. From option it's B, bending moment changes its sign. All three are important, this one and this one. Anyone they can give in option, so you should remember all three. A shaft AB is 3 meter long and is free at the left end and fixed torsionally at the right end. It is subjected to variable torque as shown in the figure. The intensity of the torsional loading is given by Q equal to 2x. The internal torque T as a function of x is how much? This is very important for GATE. So 0 to L Q dx, integration of 0 to L 2x dx, Q equal to 2x. So to take outside x square by 2, 0 to L. So it's only x square or L square. Option is A. A thin-walled cylinder with closed ends for which inner radius is 0.50 meter, outer radius is 0.52 meter, is subjected to internal pressure 2 megapascal. The absolute maximum shearing stress on the inner surface of the cylinder shall be. In GATE 2014, this question was asked. Little bit different, but Honda is same. Thin-walled cylinder. Here inner radius Ri is 0.5 meter, outer radius Ro is 0.52 meter. Thickness T equal to Ro minus Ra, outer radius minus inner radius, it's 0.02 meter. Multiply with 1000, 20 mm. Pressure how much? It's 2 MPa. 1 megapascal equal to 1 Newton per mm square. So it's 2 Newton per mm square. So absolute maximum shear stress. This is different from in-plane shear stress. It's sigma 1 circumferential stress. We have to calculate this one. Circumferential stress or sigma 1 equal to, or hoop stress you can call, PD by 2T for thin cylinder. Put 2 into diameter is 1 point outer dia, 0.52 into 2, 1.04 into 10 to the power 5 per mm into d PD by divided by 2 into thickness how much? 20. To cancel 20, it's 50. So 1.04 into 50. It will come around 52 Newton per mm square. So in this question, sigma absolute maximum, its maximum principal stress by 2. So it will come 52 by 2. Its value is 26 Newton per mm square. So answer is C. A member CD of the assembly shown is an aluminum bar 0.8 meter long. Cross-sectional dimension of the bar is such that its width is 3 times its thickness. For functional design of the bar CD, the allowable axial stress is 70 megapascal and the total elongation is not to exceed 0.72 mm. E value for aluminum, E or Young's modulus value for aluminum is 70 GPa. Assume the connection at C does not reduce the net area of the bar. The thickness of the bar in meter is, this is very important for GATE and IAS conventional. First draw the free body diagram. It's like this. Force P here and here 6000 Newton. Points are A, B, C. This one you can take like this. Take moment about B. B is 0, then 6000 into AB distance is 0.6, P into BC 0.1. So we'll get P equal to 36,000 Newton. And we know deflection or elongation. Elongation delta equal to PL by AE or A equal to PL by delta CD into E. We put the values 36,000 into L is C2 CD. CD meter you convert it in mm, 70 gigapascal. So 10 to the power 9 into 0.72. 70 GPa is equal to 70 into 10 to the power 9 Newton per meter square. So I will get here by using calculator, but in GET they won't allow, in Isro they won't allow you to use calculator. So area equal to width into thickness already given. Width is equal to 3 times the thickness, so area equal to 3t square. So 3t square equal to 5.714 into 10 to the power minus 4 meter square. So finally, if we solve this one, t square equal to 714 divided by 3 into 10 to the power 4. This quantity root over, if you do the root, you will get 0.0138 meter. In mm, you multiply 1000, 13.8 mm. In this question, 13.8 mm equal to 2 by 21 into, from option if you check this option C, it will give you 13.8 mm. It is in meters, so you convert 13.8 divided by 1000. You will get C is the answer. A simply supported beam is shown in the figure below. The location of the point of maximum moment in the beam for reaction RL is how much? It's a simply supported beam. Where moment is maximum, there shear force is 0. Here UDL. See, 4 meter, 2 meter. This is RL equal to RL already given. Reaction at A. RR reaction at C, 4 kilonewton. Here it's 3 kilonewton per meter. AB distance, BC distance given. For shear force equal to 0, take a distance x from left hand. You calculate AB shear force at x is RL minus omega. Omega equal to 3 kilonewton per meter. Omega into x. So for SFX equal to 0, you put RL minus omega x equal to 0. RL already given. So omega x equal to 8 kilonewton. So here x equal to omega also given 3. 8 by 3 meter. So in this question, the location of x, it's 8 by 3 meter. From option it's B. This is very, very important for Isro and IS and GET also. A 20 kilonewton weight is suspended by 2 wires as shown in the figure. The length of each wire is 2 meters. The steel wire E value is 200 GPa. Has an cross-sectional area of 16 to 10 to the power minus 6 meter square, and the aluminum wire E value, E is Young's modulus, 70 GPa, has an cross-sectional area of 120 into 10 power minus 6 meter square. The stress in aluminum wire is how much? Sigma at AL. Take aluminum as 1 and steel as 2. Total load is 20 kilonewton. So P equal to 20 kilonewton or 20 into 10 power 3 Newton. L1, L2 both are same. 2 meter equal to 2000 mm. E2 for steel, it's 200 into 10 power 3. It's in gigapascal, so you convert it into megapascal or Newton per mm square. Area is 60 into 10 power minus 6 meter square or 60 mm square. Convert it into mm square. E1 equal to 70 GPa for aluminum. So you convert it into Newton per mm square or MPa. A1 equal to 120 into minus 6 meter square. It is 120 mm square. Conversion of unit is very important. So elongation in 1 is equal to elongation of 2. We know PL by AE. Elongation P1 by L1 by A1 E1 equal to P2 L2 by 2 E2. L1 L2 both are same. So P1 by P2 equal to A1 by A2. A1 how much? 20 into 10 power minus 6. 10 power minus 6, both sides it will cancel. 120 by 60 into 70 E1. 70 into 10 to power 3 also it will cancel. 200 into cancel 2, then it's 140 by 200 equal to 0.7. So P1 equal to 0.7 P2. Total P equal to 20 kilonewton equal to P1 plus P2. Load at aluminum and load at steel. Already we got 0.7 P2 equal to P1 plus P2. 1.7 P2 equal to 20 kilonewton. So P2 how much will get? 20 by 1.7 kilonewton. So P1 already we got P1 equal to 0.7 P2. 0.7 into 20 by 1.7 divide 10. So it's 7 by 17. Equal to 7 into 20 by 17 kilonewton. So sigma 1 the stress is P1 by A1, stress at aluminum. So it's P1 by A1. It's 20 by 17 into A1, how much? 1 P in kilonewton. So multiply 1000. It will come 7 by 120 into 10 to the power 3 megapascal. So it is gigapascal. Sigma 1 is from option 7 by 102 gigapascal. It's D. This is a very simple question but looking like a very lengthy one. A bar of bronze and a bar of steel are placed between two immovable supports A and B as shown in the figure. The physical constants are where L equal to length of bars, A equal to cross-sectional area, alpha is linear coefficient of thermal expansion, E equal to Young's modulus. The values are given. After that, the stresses in the steel and bronze when temperature drops by 50 degrees Celsius is how much? When temperature drops, and we know when temperature drops, it will create tension, and when temperature increases, it will create compression. It will try to expand like this, so stress will compression. Whenever temperature drops, it try to contract. This side it will contract, so it will create tension. Here like this, create tension. So from option A is the answer. When temperature drops, tension will create. This is very, very important for Coal India and other exams. The point of contraflexure is a point where, this one already discussed. Point of contraflexure. This is very, very important for all exams. Where bending moment changes sign, already discussed in the previous video. Beam changes, curvature, it's a point of zero bending moment. Shear force changes sign, no. Bending moment changes sign, bending moment is maximum, no. None of the B is the answer. A circular shaft subjected to torsion undergoes a twist of 1 degree in a length of 120 cm if the maximum shear stress induced is limited to 1000 kg per centimeter square, and if the modulus of rigidity G equal to 0.8 to 10 to the power 6, then the radius of the shaft should be. The formula is T by J equal to tau S by R equal to G theta by L. This one already discussed in my previous video. Theta you convert it radian. It will come 180 is pi radian, 1 degree is pi by 180 radian. This is theta. So So in this question, the radius, they ask the radius r equal to tau s L by g theta. Put the value tau s 1000, L is 120 cm, all are in cm, so no problem, no need to convert anything. 10 to the power 6, theta is pi by 180 radian. So 30 plus 1, total 50. 8, it's 8 divided by 10. 60 cancel. Then 4 into 2, 4 into 3, 2, 9, 27 by pi. R equal to 27 by pi. D is the answer. Thank you friends for watching my video. If you like my video, then subscribe it.